Okay, welcome to this session. So in this session, we are going to discuss how we are going to use a nested try statements, or how we are going to put a try block inside another block, and we'll discuss about the other keywords, that is throw, throws, and finally. And we are going to even with an example see how we can make use of user-defined exception class, and even with the chained exceptions too. And so now, in the previous session, what I have discussed as the fundamentals of exception handling, I just told you it is all about the 5 keywords what I use in the Java program. That is the try catch keyword, what we have already discussed, how we are going to make use of try, how we are going to make use of catch clause or the multiple catch clause with respect to the class hierarchy of your exception class in your Java program. And so please remember this hierarchy of exception class in your Java, where the topmost is throwable class, and next followed by exception, which is the subclass of throwable, and whatever the exception we are going to have, it's going to fall under runtime exception. And in the previous session when I was discussing, the arithmetic exception was the subclass of exception, not the subclass of runtime exception. So in a few versions, the arithmetic exception becomes the subclass of exception, and in few versions it becomes the subclass of runtime exception. But the newest version or the new versions what is available, it is going to make the arithmetic exception to be the subclass of runtime exception. So in any other way, the arithmetic exception is going to be the subclass of the exception class itself. But specifically now we'll put the arithmetic exception as a subclass of runtime exception, and even few more classes, that is index out of bounds exception, again the subclass of the runtime exception, and a null pointer exception, again the subclass of runtime exception. I have just put only the few classes over here. There are few more classes which is going to be the subclass of runtime exception, as well as few subclasses which is going to be the subclass of exception also. And remember, there was one more important subclass of throwable, that is the error class. Fine. So we are not going to discuss much about the error class, hence I have not depicted that in this class hierarchy right now. Fine. And with this, so in this session we will clearly know how we are going to make use of the try keyword and the throws keyword and the finally keyword. So we are going to see this 3 keyword, and even we will see how we are going to create the nested try block. But remember this general structure of the try catch clause and how we are going to use the final clause also. And so when I talk about exception handling, this is the general structure of what the try catch final is going to be. Now we will just discuss nested try, and next we will see how we are going to make use of the other keywords too. Fine. So now if I talk about nested try statement, so right now just observe, this is the same example what I had used in the previous session in the fundamental of the exception handling. So now I am just going to have a try block as usual what we have done until now, and I am going to have multiple catch clause attached or associated with this try block. And so now I am going to have arithmetic exception when the value of b is 0, and I am going to get array index out of bound exception when I am accessing an array index which is not available or which is not allocated. Fine. And so now when I execute this particular program, I am going to get the output as s. So this b equals 0, hence 10 divided by 0. And so at this statement I am going to end with arithmetic exception. Hence immediately the exception is thrown, and this catch clause is going to catch that exception and prints the message I am 0 at the level 3. Fine. So now if the b was not 0, so which we'll see in the next example. So now once I am going to get the output as I am 0 level 3. Now let me modify the same program. Modifying the same program, as I told you, I'm making b as no non-zero value, something like b equals 10. So now there is no exception in this case, hence the control will shift to the next statement. So just look at what has made the difference here. When the exception occurred, So the point where the exception had occurred, hereafter none of the statement in the try block is executed. Immediately the control will shift the catch clause. If there is no matching catch clause, even though the control will shift, and by default the default handler will come into picture and it will handle the error. But right now when the b is 10, this becomes 10 by 10, hence there is no any exception here. But when I enter this statement, now I am accessing an array index which is not available because array contains only 3 elements. That means the only legal index values of D starts from minimum 0 and maximum 2. From 3, even if you use D of 3, is going to be illegal operation. Anything greater than 3, anything less than 0 becomes illegal operation with respect to the array index. Hence, at this point of time, it is an exception which is going to be array index out of bound exception. And now this is going to match. Hence, when I throw this error, now this catch is going to catch the error what has been thrown, or the exception what has been thrown. Hence, this catch statement was skipped because it is not an arithmetic exception. It was an arithmetic exception as this catch had handled the error and this was not handling. Right now is the other case. Hence, if a try block has got multiple catch statements, any one catch statement will be executed. Remember this. It is something similar to switch statement. Whichever the case is going to match, only that case will be executed. Remaining all the cases will be skipped out. Similar to that. And so now for this program, I am going to get I am bound at level 3. I hope this example is clear now. So right now still I have not created nested try statement. It is a simple try statement itself. Now we will just put into a nested block where the program is going to look something like this. Just look at this. So this try block and its associated 2 catch statements I have put inside the try block. Now just observe this. I have put inside the try block. And now this try block becomes the outside or enclosing try block, and this try block becomes the nested try block or the inner try block. Hence now for this try block there are 2 catch clauses, whereas for the outer try block there is no catch clause. Hence, if any error this try block is going to throw, in this case such things is not going to happen. If any error this try block is going to throw, there is no catch clause to hold the or catch that error. And in that case, the default catch handler will come, default Java exception handler will come into picture and it is going to handle the error. It's fine. So now if I execute this program, I am going to end with same output because B is 0. It is going to be arithmetic exception. Immediately this has been caught and I am going to say I am 0 level 3. Fine, the same output, nothing has been changed even if I have used nested try statement. So now we will just still modify this program now. I am going to again enclose this try statement with one more nested try. Now just look at difference what I have made. I have just not created the nested try with one more outer try, but just observe what the other modification I have done here. Now the catch array index out of bound exception is matched with the inner try block, and I have removed this arithmetic catch exception clause and I have taken it out of the inner try clause and I have attached or associated this with the second outer try. So for this try I am associating with this catch. Hence for this try there is one catch clause. For this try I am going to have one more catch clause or its associated catch, and for this try there is no catch clause, hence the default handler will come to a picture in this case. So now if I execute the output, now clearly observe what is going to happen. Fine. So now when there is an exception here, int a equals 10 comma divided by 10 divided by b, b is 0, hence for sure there is a arithmetic exception. Now what happens? Just observe now what happens. this exception is immediately thrown by your try clause. That's the innermost try clause. And this associated catch clause doesn't have a catch clause which can handle the arithmetic exception. Now this is not an array exception or array index exception, and so this catch clause will not be executed. Remember this. So now what does this do? In this case when no catch clause is matched, as we've discussed, the default catch handler should be called. But in nested try statement, that will not be done straightforward. If no catch clause is matched for the innermost try block, in that case the next associated try block catch clause will be used. That means now this try block, when it doesn't have its matched catch clause, the error will be passed on for the next try block. Now this try block should handle the error for arithmetic exception. So now just observe, do this try block has its associated catch clause which can handle arithmetic exception? Yes, it can handle. And so now I am going to print this output as I am 0 level 2. And by this example, just understand, if the innermost try block, if it has not any catch clause which it can handle the exception, then the surrounding or enclosing try block of it will handle that exception with its catch clause. Again, we can go further. Even if that middle try clause doesn't have a catch clause which can handle the exception, it will go one step above for the outermost try clause. That is what we will see next example. Now just look at this example now. I have just moved the arithmetic exception out of the second level try clause. Hence now when the exception occurs, the arithmetic exception occurs in this case. Now this is not able to handle this exception. Hence the default handler is not called. Remember, the exception will be now handled by its enclosing try clause. Now when I come at the enclosing try clause, this try clause doesn't have any catch clause. And so now it cannot handle the error. Hence the exception will be thrown or should be handled by its enclosing try clause. Now its enclosing try clause is going to have a catch clause which is going to handle arithmetic exception. Hence I am going to print the output as I am 0 level 1. So the output what I am going to get. Hence if the innermost try clause cannot handle the exception, then it will move one level up. Even if it is not able to handle, it will move one level up. Hence the level will be keep on shifting try by try clause until any one of the try clause is going to handle the error. If none of the try clause is able to handle the error, in that case the default handler will be called. Hence the default handler will be called only when all the try clause has been exhausted. Remember this. Hence this is how the nested try statement is going to work. Now just look at this. I am just going to have the try clauses. Now none of the try clause has an catch clause which can handle the arithmetic exception. Hence in this case all the try clause has been exhausted without handling the exception using its own associated catch clause. In that case the default catch handler will be used. It is going to print divided by 0 error. Now this is what the try statement is going to work in this way. Fine. Hence, so just to put this explanation what I made, I will just say try statement can be nested. Yes, it can be nested. A try statement can be inside the block of another try. So if we say it's a nested try statement, yes, a try statement can be or should be inside the block of another try statement. If a inner try statement does not have a catch handler, what it does? Yes, the next statement's catch handler inspected. The next level try statement's catch handler inspected for the match. Even if that doesn't matches, this continues until one of the catch statements should succeed of the outer nest or the try statements, or until all the nested try statements are exhausted. if it should succeed with any matching of the catch statement, or all the try blocks should exhaust. Hence, when all the try statements exhaust, and even if you don't catch the matching catch statement or the catch clause, in that case the default handler is used to handle the exception. This is how the nested try statement is going to work. Now just look at one more example here. Just look at one more example. So now in this example, I have just included all the type of errors. Just look at this. I am just going to have the main function, and I am going to have a command line argument into my program. Now my program is going to work on command line arguments, something like when I say Java, and if I execute my program nest try by passing no parameter for my program through command line, so we say it's 0 argument. If I am passing 1 argument, we say it has got 1 argument or 1 parameter. If it has got 2 strings associated with the execution of my program, we say it has got 2 parameters or 2 arguments. So it depends how many you pass. Hence, the program is going to work on command line arguments. So now just look at this. When I execute the main function, the main program, now I'm going to say int a equals argument s args dot length. Now this is going to be length, the number of parameters what you pass. Now in this example input case, the length is 0, the length is 1, and the length is 2. Hence the value of a will be 0 in my first execution. Hence b equals 42 divided by 0. Hence it is an arithmetic exception. Immediately the execution halts or stops, and the control will shift to the catch clause. Now just observe, this try clause doesn't have its matching catch clause. Does it has a matching catch clause? Because now this is the try statement. This is the try statement. It starts from this block until this block. So when this error is encountered, immediately the execution will come out of this try block, as this try block has got an arithmetic exception catch clause. Hence whatever the exception I have encountered now, it's an arithmetic exception. Hence in this case I am going to print system.out.println I am 0. So fine, hence I am going to get it as I am 0. Hence, so the outer try block itself had got an exception and its catch clause was executed. I had never a chance to go forward with the execution for the inner try block. The control never entered the inner try block. This is fine. So now in the next execution where I pass 1 parameter, the value of a becomes 1 and b equals 42 by 1. Hence there is no any error. The execution will come at this statement, and I am going to print the value of a equals 1, and I will enter the inner try block. So if a equals 1, yes, it is true right now in this case. So a equals a divided by a minus a becomes 0. Again there is a arithmetic exception here. Immediately the control will shift out of the try clause, and there is no catch clause of the inner try clause which can handle the arithmetic exception. In this case, it will forward or it will pass on the exception to its enclosing try clause. The enclosing try clause has got an arithmetic exception clause, and it's going to print the output as I am 0. And in the next execution where I pass 2 parameters, a becomes 2 and b equals 42 by 2. There is no arithmetic exception. I print the value of a as 2 and I enter the inner block, and there is no any error. There is this statement condition becomes false because a is 2, 2 equals 1, it's false. I will jump to next condition. This condition is true, and I'm going to say int c equals 1. I'm creating one element in the array, hence the only allowed index values c of 0. Any other index value use, it is going to throw an exception array index out of bound. Hence in this case it's a syntax error, or it's an exception. Right now it's an exception, hence immediately this will be thrown to the catch. The catch is able to handle the error. I am going to print this as I am bound, And once the exception has been handled, so the exception is not forward for any outer try block. Once it is handled, it is done. So I'm going to get the output as I am bound. So this is how the nested try statement is going to work for any multiple case. And if any other input I'm going to pass, if I pass 3 parameters, there will not be any exception. There won't be any exception. Only for these 3 types of input, I'm going to get 3 types of exceptions. Any other input what I'm going to pass, you're not going to get any exception, and the program work as usual without executing any catch clause. Fine. And just look at this one more example now, where I bring in the concept of method, that is calling a method inside an try block. And if that called method contains a try block, again this we call this as nested try. We can create the nested try along with the method call also. Just observe now. I am going to have a main function where the main function has a try clause. Inside the try clause, I am going to have a method call or a function call. And if that function call contains a try block, we say the try block of the called function is nested inside the try block of a calling function. That is what we say, the try nested block with respect to the method function. Hence we are going to have class method nest try. I'm just going to have a class and I'm going to have a method called as nest try. I'm just going to have a method called as nest try, which takes 1 parameter, and inside this method I'm going to have a try block, where in this try block I'm going to have same statement what I was using here. So this entire process I am putting inside a method. This try block and this catch clause I am putting inside a method. And I am just going to have main function, where in this main function I am going to have a try clause, the outer try block, where I am going to have the argument length. I am going to print this value, and in place of this set of statements I am calling it nested procedure and the same exception. Now this is almost equivalent to this program itself. So though this try block is in a different procedure or different function, and this try block is in different procedure or a function, the function call is inside this try block. Hence we say this try block is nested inside this try block, because when an exception has been occurred inside a method, if it is not able to handle, as we know, this will pass on to the called function try block. Now this is going to work similar way what it was working with the same program. Fine. The only thing is I am put those nested or the try block inside the method, and I have put the method call inside a one more try block. This is again the nested try statement is going to be work like. At this point of time we have discussed about the try keyword, the catch keyword. Now we will see how the throw is going to work. Further we will see how the throws is going to work and how the finally keyword can be used. So now if I talk about throw, until now whatever the exception was thrown from the try block to a catch block, it was executed or created by the Java runtime. Java runtime created the exception whenever there are runtime error, and that exception was thrown by the Java runtime every time by default. But now using the throw keyword, you have a chance to throw the exception by yourself as a programmer in your program whenever you want. Hence you need not wait to occur a runtime error to throw an exception. Whenever you want, you can throw an exception. That is what the usage of throw keyword is going to be. And whenever you make use of throw keyword and whenever you deal with the exception handling, so please remember this class hierarchy. And so now when I'm going to have a try clause, try keyword or throw keyword, just remember this. This is the syntax of using a throw keyword. So now I'm going to use a throw keyword space. I'm going to use any of a throwable instance. That is, I'm going to use the object of the throwable class. This should be the object of throwable class, or it can be the object of the subclasses of throwable. Hence, I can use the object of exception, I can use the object of runtime, I can use the object of arithmetic exception, index out of bound, null point exception, or any other object of the class which is going to be the subclass of throwable either directly or indirectly. And that is what the throw keyword can throw only the object or the instance of the throwable class or the class hierarchy of the inheritance. And so this can be any object of this given class hierarchy. But if we talk about non-throwable objects, something like objects of any other classes or the object of the string or any object, so you are not supposed to pass this as an parameter, or you cannot throw this as an exception object. And even the primitive type, something like int, character, double, float, even you are not supposed to throw any variable of the primitive types also. And so these two are not allowed whenever you use the keyword throw and when you're trying to throw an exception. That is, if you're throwing an exception, it should be an object of any class or the subclass of the throwable class hierarchy. Remember this point. And with this, whenever we are going to have, or whenever we are going to throw an object, we have got two ways to obtain a throwable object of any of this class. We have got two ways. The first way is we are going to use any of this class object in the catch clause parameter. As a catch clause parameter, what we are doing. So when I throw an exception, you need not create an object. So just use it as a parameter in the catch clause. It is going to create an object and I can use the throwable instance. And the second important way is I'm going to use the new operator. I'm going to use a new operator to create the object for any of this class. Hence, if I using it as a parameter, it is the by default what you are doing until now using a catch clause. It is not going to give me enough advantage of using a throw keyword. If you are using a throw keyword, you make sure you use a second way of doing this. That is, we are going to make use of the new operator to create a new object of any of this class. Is it clear? And now this is how we are going to get. Now just look at the example how we exactly do this. Now I'm just going to have a class. In this class I'm going to have a main function. The main function calls a procedure inside a try block, and this try block has got a catch clause which can handle the null pointer exception. Fine. So now in this procedure I'm going to have one more try block. Now just observe, now this try block becomes the nested try block of this try, and now this try becomes outer block and this try becomes an inner block. And now just observe, this is where I am using the keyword throw. I am creating a new exception here. So now I am not using anything divided by 0 here. I am not using any array index out of bound. No such statement which can create exception and the Java system will throw that exception automatically. I am not using any such statement. As a programmer, I am creating an exception here. As throw is the keyword, and I am going to use the new keyword or new operator, the second way of creating a throwable instance object. And the throwable instance object what I am creating is the null pointer exception. Remember the class hierarchy. This was the subclass of exception class, where the exception class is intern, the subclass of throwable. And so now I am going to create the instance or the object of this class by calling the constructor, which is going to be 0 parameter constructor. I'm calling the default 0 parameter constructor. When I execute new and by calling constructor, this is going to create an throwable instance. I have created the throwable instance, and now this exception what I have created I am throwing. Now this is how I am going to throw the exception as the programmer myself. When this has been thrown, so this catch clause is going to catch this exception, null pointer exception E, and I'm going to print this output caught inside the procedure. I'm going to print this as output, and this is the output what I'm going to get caught inside procedure as the first output. So now just observe one more point here. I'm again throwing E. What is E? E was a null pointer exception which I had created. So now this statement has thrown an exception, the same exception I am rethrowing. I am rethrowing the same exception now. So once I am rethrowing this inside this catch clause, now this catch has already handled the exception. Now again this catch clause cannot handle one more exception. Is it fine? And so when I say throw E, I am rethrowing the same exception. When there is no match clause, it will go for the outer try clause. When it goes for the outer try clause, it is going to have one more catch clause. Now this catch clause can handle the same error which has been rethrown. Hence, I am going to have this catch clause. I am going to print the output as caught again, and I am going to print the complete stack trace what the error was. I am just going to print the null pointer exception, and which is going to be divided by 0 because there is no any error what it is going to print. And now this is how the throw is going to work for you in your program. Fine. So now just look at this one more example of throwing. So now in the previous example what I have explained about the throw keyword, it was using 0 parameter. It was using 0 parameter. But now I am using a parameterized constructor where I am going to pass a string for the message what I want. In the previous example, I had the default message for null pointer exception as divided by 0 because there was no any other exception which has been occurred. But right now I am putting my own message now using a parameterized constructor which takes a parameter as a string, where previously I had used 0 parameter. And so when I execute the same execution, but now I'm going to print my own message as I am null. I can do this, or I can pass the what message I want by using parameterized constructor of any throwable class. Is it fine? And anywhere in between, if you want to print this message, I can use the inbuilt method which the throwable class has got as e.getMessage. This will print I am null wherever you want in your program, whenever you are going to call this message after creation of the object E. Now this is how the throw keyword will be used in your Java exception. Thank you.